This is Bob Capetta from the University of Illinois at Chicago, and this is a final exam review for Math 121, problems 1 through 4 from the Part 1 review. The first question is to expand the natural log of x to the fifth times the cube root of x plus 7. You've got to remember that the log of the product is the sum of the logs. This will be natural log of x to the fifth plus natural log of the cube root of x plus 7. And of course, a cube root of x plus 7 is the same as x plus 7 to the 1/3. This will give us natural log of x to the fifth plus natural log of x plus 7 to the 1/3. Then we can pull down the exponents. It'll be 5 log 5 and 1/3 log x plus 7. And if we wanted to rewrite that, 1/3 of log x plus 7 would just be natural log of x plus 7 over 3. So expanding this first piece using the rule of logs gives us 5 times natural log of x plus natural log of x plus 7 over 3. Our next example is log of x minus 2 to the fourth square root of x over the fifth root of 2x minus 3. If you see log, remember that's log base 10. So I am seeing this as a quotient, log of the top over bottom, which is the log of the top minus the log of the bottom. Log of a over b is log a minus log b. Now we can do the same thing here. Square root of x is x to the 1/2, and 2x minus 3 to the 1/5 power represents the fifth root of 2x minus 3. Also recognizing the log of the product is the sum of the logs. So the log of x minus 2 to the fourth root x is log of x minus 2 to the fourth plus log root x minus this piece, log of the fifth root of 2x minus 3. Rewriting these things, square root of x is x to the 1/2. Fifth root of 2x minus 3 is 2x minus 3 to the 1/5 power. Now I can pull all the exponents down in front, pull the 4 down in front, pull the 1/2 down in front, pull the 1/5 down in front. And we get 4 times log x minus 2 plus 1/2 log x minus 1/5 log 2x minus 3. Of course, 1/2 log x is log x over 2, and 1/5 of log 2x minus 3 is log 2x minus 3 over 5. Our next case is to solve an equation log x plus log x minus 3 equals 1. Now before doing any log equations, remember you cannot take a log of 0, you cannot take a log of a negative number. The logarithm functions are only defined on positive numbers. Well, here we have log x plus log x minus 3. The sum of the logs is the same as the log of the product. So log x times x minus 3. Also remember log means log base 10. So just clarifying that issue, I'll put a 10 in there, log base 10 of x plus log base 10 of x minus 3. And then again, the sum of the logs is the log of the product. At this point, 10 to the first power, remember this is the base 10, so this is an exponent, 10 to the first power equals x times x minus 3. So 10 is x squared minus 3x, subtracting 10 from both sides. 0 is x squared minus 3x minus 10. Which we will factor as x minus 5 times x plus 2. So x minus 5 is 0 or x plus 2 is 0, so x is 5 or x is negative 2, except if you plug negative 2 in, log negative 2, not acceptable. Log negative 2 minus 3, log negative 5, not acceptable. Negative 2 is not in the domain. You cannot take a log of a negative number. Log 5 is okay, 5 minus 3, log 2, that's okay. So the only answer I have here is 5. That's the only one that is in the domain of the function. Next we have log base 2 of x minus 1 minus log base 2 of x plus 5 equals 3. Again, you cannot take a log of a negative number. Keep that in mind. Log a minus log b is log a over b. So this will be log 2 of x minus 1 over x plus 5 equals 3. At this point, 2 to the third power. 2 to the third power, base is 2, exponent is 3. 2 to the third power equals x minus 1 over x plus 5, or 8 equals x minus 1 over x plus 5. Multiplying both sides by x plus 5, we'll get 8 times x plus 5 equals x minus 1. Distributing, that's 8x plus 40 equals x minus 1. Subtract x from both sides, so 8x minus 1x is 7x. Plus 40 is negative 1. Add negative 40 to both sides. Divide by 7. X is negative 41 over 7. Except, if I plug negative 41 over 7 into this value, log base 2 of negative 41 over 7, that's a log of a negative number. That's not acceptable. That's not in the domain. Similar kind of thing happens with this piece. Negative 41 over 7 is not allowable as a solution. So this problem has No solution. No solution in the domain of the log function. Next, we want to find zeros in multiplicity, find the y-intercept, describe the end behavior, and sketch a graph for f of x equals x cubed minus 9x. So if we're going to look for zeros, let's set that equal to 0. So, which we'll do in a minute here. Factoring x times x squared minus 9, x times x minus 3 times x plus 3, setting that equal to 0 gives me x is 0, x minus 3 is 0, or x plus 3 is 0. So notice all of those have multiplicity 1. This is to the first power, this is to the first power, this is to the first power. So x equals 0 has multiplicity 1, x equals 3 has multiplicity 1, x equals negative 3 has multiplicity 1. And that tells us what's going to happen when we're graphing the function. It's going to pierce the x-axis. It's not going to bounce or flatten out. It's going to pierce. Next up, we want to find the y-intercept. So that is the y value when x is 0. So if I plug 0 in for x, what do I get for y? 0 cubed minus 9 times 0. F of 0 is 0, so the y-intercept is 0. Now, how about end behavior? Well, this is highest power is third. This is x to the third power. So it's going to behave like x to the third, odd power, and the coefficient is positive. That's 1x cubed. So it's an odd power with a positive coefficient. Knowing that, it's going to behave like positive 1x cubed. Now, what does x cubed look like? Goes down to the left, goes up to the right. So we can look at a quick graph of that. So the end behavior of our function will look the same way. So again, down to the left, up to the right. And if we're going to write it in terms of limits, as x goes to positive infinity going this way, f of x goes to positive infinity. As x goes to negative infinity, f of x also goes to negative infinity. That's our end behavior for that function. So if I want to sketch a graph, 0, 0 is my y-intercept. Notice multiplicity 0 here. Negative 3 multiplicity 0. 3 multiplicity 0. Piercing. Nothing is bouncing. Down to the left, up to the right. Down to the left, piercing through, up to the right. And that gives us a graph of that function. Same directions. This time we have negative 1/3, x plus 1, x plus 3 times x minus 1 squared. Setting that equal to 0. Negative 1/3 cannot be 0, but x plus 1 could be 0, x plus 3 could be 0, x minus 1 squared could be 0. This will be our multiplicity to 0. So with this one, adding negative 1 to both sides, x equals negative 1 with multiplicity 1. That will pierce. X equals negative 3 multiplicity 1. Here, x equals 1, though, with multiplicity 2. That is going to bounce. So we'll keep that in mind. Regarding the y-intercept, we're going to plug in an x value of 0 to see what g goes to. So what is g of 0? 0 plus 1, 0 plus 3, 0 minus 1 squared. 1, 3, negative 1 squared, which negative 1 squared, of course, is just 1. So 3 times negative 1/3, we get g of 0 is negative 1. So the y-intercept is x is 0, y is negative 1. Now regarding the end behavior, what's my order here? X to the first, x to the first, x to the second. This is like its order 4. But the leading coefficient is negative. So we have that situation. So it's going to behave like an even power with the leading coefficient is negative. Even power x squared, leading coefficient is negative. It's going to behave like negative x squared. What does that look like? Upside down parabola. Down to the left, down to the right. That'll be our end behavior. As x goes to positive infinity, the function goes to negative infinity. As x goes to negative infinity, the function goes to negative infinity. So that's how we can describe our end behavior. So we have our zeros with their multiplicity, we have our y-intercept, we have our end behavior. So it's going to bounce at 1, pierce at negative 1, pierce at negative 3. So there's your y-intercept at 0, negative 1 there. It's bouncing at 1, piercing at negative 3, piercing at 1. Notice down to the left, down to the right. So this is a graph of what that function will look like. Okay, this time I'm giving you the graph and you have to give me the formula. So we have zeros with multiplicity. What do we have here? Negative 3 is a 0, negative 1 is a 0, 2 is a 0. Negative 3 has multiplicity of 1 since it's piercing. Negative 1 has multiplicity 2 because it's bouncing. 2 has multiplicity 2 because it's bouncing. So how do we make sense of that? If x equals -3, that means x plus 3 is 0, multiplicity 1. X equals -1, x plus 1 is 0, multiplicity 2. X minus 2 is 0, multiplicity 2. What do I mean by that? We'll get x plus 3 to the first power, x plus 1 to the second power, x minus 2 to the second power, with some multiplier in front. The y-intercept will help us find that multiplier. So looking at the picture, it appears as if the y-intercept is -3. So when x equals 0, y is -3. And this is order what? 1, 2, 3, 4, 5. Order 5 odd power, up to the left, down to the right. That makes me think that a is probably going to be negative. So when x is 0, y is -3. Plugging 0 into this function, what do we get? -3 is f of 0. A times 0 plus 3, 0 plus 1 squared, 0 minus 2 squared. -2 squared is 4, times 3 is 12, so we get what? -3 is 12a. Divide by 12. -3/12 is a. -1/4 is a. And then just go ahead and replace that a with -1/4, and we have a representative formula for the given function. And one more sort of problem. Notice our zeros here. -2 bounces, multiplicity 2. -1 pierces, multiplicity 1. +1 flattens out. That'll be multiplicity 3. So similar kind of argument. If x is -2, x plus 2 is 0. X is -1, x plus 1 is 0. X is 1, x minus 1 is 0. But x plus 2 has multiplicity 2. That'll be x plus 2 squared. X plus 1 has multiplicity 1, x plus 1 to the first. X minus 1 has multiplicity 3, x minus 1 cubed. And then it's our job to find out what that leading coefficient is. What is a? We're going to use the y-intercept to get there. Notice the y-intercept here is -2. When x is 0, y is -2. So plugging in 0 to this, we're going to get what? -2 is f of 0 is a times 0 plus 2 squared, 0 plus 1, 0 minus 1 cubed. So -2 is 2 squared times 1 times -1 cubed times a. 4 times 1 times -1a equals -2. So what is that? -4a. -2 is -4a. Divide both sides by -4. So -2 over -4, or 1/2 is a. And then go ahead and plug in the 1/2 for a in terms of our f of x. And we get f of x is 1/2 times x plus 2 squared times x plus 1 times x minus 1 cubed. And that will conclude this lesson.